In this video, we want to look at some very, very basic algebraic functions and just classify them, give them names. Uh, and these functions all have to do with the power of the variable, okay? So here we classify basic functions based upon the variable's exponent. Okay, so that's the key here. And I want to remind you, you may already know these equations. Um, if you have an equation like y equals 3, then that is a horizontal line, if you were to graph it, through the y-axis at 3, okay? And, you know, there's nothing special about 3. That was just an example. Um, but the idea is when there's no variable here, you get a horizontal line, okay? Um, also, what if, so that's the case where there is no variable. It's like the variable is raised to the 0 power, kind of. There's no x, is what I mean by that. I'm sorry. There's no x here. All right? Um, and in fact, let me go back. Here we classify basic functions based upon x's exponent. That's typically the variable that you will use in a function. So, all right, let's go back here. And if we look at something like this, y equals 2x minus 5, now you can see that you do have x to the first power. And x is to the first power, y is to the first power. Um, this graph is a slanted line. It has a slope. Um, and you may recognize this as y equals mx plus b. You don't have to, but you may recognize it as y equals mx plus b, meaning that the slope is 2, or 2 over 1 if you want rise over run, and the y-intercept is the ordered pair 0, negative 5 from this b value, okay? But really, it's a slanted line because x is raised to the first power. Now, um, what we do now is take, hopefully you recognize those. If not, maybe now I've jogged your memory. Um, now we write these as functions. So all we have to do, we have to replace the variable y with something like f of x to make it look like a function equation. It could be g of x, it doesn't matter, h of x, etc. Okay, it doesn't matter what we replace it with, just a function notation. So what we see is, if I write this first one in function notation, it looks like this: f of x equals 3. And so the output of this function is 3, no matter what your input is. This is called a constant function because the output does not change as you change the input. Just like up here, y equals 3. They're the same equation, okay? They're the same equation. Y equals 3 is the same equation as f of x equals 3. And you can see that y is going to be 3. Your output y will be 3, no matter what x is, okay? So that's a constant function. So that's one of the first functions we'll look at. The graph of a constant function is a horizontal line. The y value doesn't change. It's the same all the way across. Okay, next. F of x equals 2x minus 5 contains x to the first power, as we said before. So it is a slanted line. We call this type of function a linear function. Linear because it's a line. Now, some people may call f of x equals 3 a linear function as well because it's also a line, but we can be more specific by saying it is a constant function, meaning its y value doesn't change. In a linear function, because it's a slanted line, the y values do change. Okay, so the thing that makes it linear is the fact that the variable is to the first power. That's what makes it a linear function. Above, it's a constant function because there is no x. Let's see. The output does not change as you change the input because there is no x. Okay? So that's important. All right, lastly, one we haven't discussed yet, you may not be familiar with. F of x equals x squared minus 2x plus 3 let's say this, has x squared as the highest power of x. This is called a quadratic function. Think about square, like squared. Think about the geometric shape of square. It has 4 sides. So for quad, 4 sides, a square. This is called a quadratic function. And the key is you can't have any higher powers of x than x squared. You can't have x cubed, x to the 4th, etc. There are no higher powers of x. Okay? It's called a quadratic function. It graphs as what's called a parabola. And we're not going to actually worry about graphing it right here. We just want to classify, be able to recognize what types of functions these are. A parabola looks like this sort of curve going down forever, opening in the downward direction, or opening up like this. Those are parabolas. And that's what you get when you graph a quadratic function. So here, on a constant function, you get a horizontal line. On a linear function where you have an x to the first power, you get a slope and you get a slanted line. Doesn't have to have that exact slope, but it could have a negative slope too. And lastly, whenever you start raising the variable to higher powers like squared, you start curving the line instead of getting straight lines, okay? All right, so there are constant, linear, and quadratic functions.